Okay, so let's look at this one. These two are going to be special cases. So if I go over 2, so I start at the origin, go over 2 and up 3 and put a point there. And then I go over 5 and up 3 and put a point here. And I draw the line. Notice that it is going to look like that. All right, it's going to be a horizontal line, and again, hard for me to draw with a mouse, but you're going to have a straight horizontal line. If I do the slope, I can do it again 2 ways. I could do rise over run. So let me do that. So how much am I rising? Well, notice from one point to the other point, there is no rise. So 0 rise, but how far did I run? Well, I ran 3. 0 divided by 3, remember, is okay. And the answer is 0. So the slope here is 0. Now, let's look at our little input-output chart. So 2, 3, 5, 3. And again, I'm using the mouse just because it's easier for me to graph that way. Here, the change in y is 0. Here, the change is it went up by 3. Again, change in y over change of x, or change of y over change of x is still 0. So my slope is 0. Now, I like to think of this, if you think of someone skiing here. All right, there's their ski poles, I guess. Notice they can ski. It's going to be boring, right? But it's going to be like cross-country skiing. So you can ski on a flat, snowy surface, cross-country, but the slope is 0. There's no tilt to the ground if you're on a flat surface, but there is slope. It just equals 0. If you do the y2 minus y1 formula, you're still going to get either 0 divided by 3 or 0 divided by -3. Still going to be 0. All right. Let's look at this one. We have 2 3s, so I'm going to go over 2 and up 3, and then 2 5. So notice this time we have a vertical line, if I could draw. So if I do my input-output chart, let's see. So 2, 3, and 2 5. This is going up by 2. This is going up by 0. So 2 divided by 0 is a knockout. That is not okay. This one does not exist. There's no solution. And it's almost that it's infinite steep. So we can't put a number on it. If we do rise over run, I'm rising 2, but I'm like, there's no run here, but it's infinite steep. And I'll talk about what I mean in a second here. Again, if I put a skier on here, this is not boding well. They're trying to ski down a cliff, right? That's not good. So it's impossible to ski on this. Therefore, that's a way to remember no solution. Now, as far as if you were asked to write the equation for these are also not going to fit your nice equal y equals mx plus b format. One of them kind of does, but it's usually a better idea to kind of just have these in the back of your mind, what's going on. So one of these is going to be x equals a number. One of them is going to be y equals a number. And so if we look here, if I graph this, do you see that y is always stuck at 3? So like I could, here's another point stuck at 3, another point. So the y value is always stuck at 3. But notice what can happen to the x. The x value can vary. It can be whatever it wants. So the formula for this is just y is stuck at 3. There is no x. Technically, it does fit y equals mx plus b form because 0 times x plus 3, 0 times anything is 0, so that goes away. But again, if you notice that we have a weird situation here, we have a horizontal line, y is stuck at 3. The x's can vary. That's why the x doesn't matter. The variable x doesn't matter because you're always stuck at 3 for the y. So no matter what your input, you're stuck at that. An example would be like that, kind of like right now I might be working 60 to 80 hour work weeks here coming up, but I'm salary, right? So no matter how many hours I work, my salary is at that same point. My paychecks are not going to change. If I were hourly and I suddenly worked more and more and more and I was working 60 to 80 hour work weeks, then my salary would go up and up and up and up, and it would have a slope because I'd be getting paid a rate. But a rate per hour. But if your salary, you're just kind of at this constant salary, and some weeks, sometimes in history you have to work more than others. All right, let's look at the next one over here. Let's see, same thing for writing equation. Notice here, it's again a weird situation. So anytime you have no slope or undefined slope, something's going on. So notice here the x's are stuck at 2. So again, the y's can vary. The y can be whatever it wants. So the y's, I don't care what the y values are, but the x is stuck at 2. So the y's don't really matter in the formula, just the fact that it has to be stuck at 2. I always kind of remember it's backwards of the axis. So this is the x-axis. So the formula is y equals a number, and this is the y-axis goes up and down, so it's x equals a number. But you can kind of try to think about that however you would like. All right, so down here, I just want you to think about it. If you're here, you can ski on it, right? It's boring. The slope is 0. And then say I do rise 1 and run 4. So I rise 1 and run 4. So that might be a line like that. And maybe I rise 1 and run 2. So I rise 1 and run 2. And maybe that's over here. And I maybe rise 1 and go over 1 or something like that. And then notice happen if I go 4 over 1. Well, then I might rise 4 and run 1. And maybe if I rise 10 and run 1, rise 10 and 1, and then happen if I rise 100 over 1, it's going to be steeper and steeper. So in a sense, this line is almost infinite steep. If I add 100 over 1 slope, or 10,000 over 1, or 100,000 over 1, it would get closer and closer and closer and closer to this line. So mathematically, it's undefined, but it's almost like it's infinite steep. And then on here, we get the negative ones. You can see though how these have negative slopes. And then we get back to 0 again. All right, go ahead and turn to the next page. Look at the triangles there. We'll talk about pitch a little bit, and then we'll try number 4. Okay, usually with pitch, we're talking about a roof. But, you know, in this scenario, I highly doubt it's a roof because our units here are inches, not feet. But if you look, the rise, it's rising 5 over the run of 12. And again, yes, they were in inches, but again, ratios are unitless. So you see if those cancel, then there is no units. It's just a rise of 5 for every 12. It could be feet, it could be miles, it could be anything. Here my rise is 6 over my run of 12. Again, units would cancel. And that simplifies to a half. So what that means is if I rise 1 and run 2, I'm going to be up here. If I rise 1, run 2, rise 1, run 2. So it's basically, we have all these infinite many proportional triangles inside here that have that same ratio. And then this last one, rise over run, is 12 inches over 12 inches. And again, if your units don't match, if you have feet and inches, you might have to convert one. And that's a 1-to-1, or we could just say the slope is 1. So again, pitch, grade, remember grade again, like if I have a 5% grade on a road, it means 5 over 100. Again, unitless, but you could put a unit on it. So you could say for every 5 feet over 100 feet. So rise over run, for every 100 that I run, the road is going to go up 5 feet. And then that's kind of the grade of the road, how steep it is. Especially important with mountain bikers and in the winter with truck drivers in Colorado mountains. All right, go ahead and try to see if you can figure out number 4, and we will come back. Okay, so let's look at this problem. So my dog is snoring in the background. I don't know if you can hear or not, but we have a ledge, right? And there might be some type of door up here. And we need a ramp to make it compliant with ADA rules so that people with wheelchairs could get in it. So it should be a right triangle here. I'll see if I can draw it better. So there we go. All right, and if you look that it's 12 inches off the ground. Now they want our answer in feet. So I am going to go ahead and say that this is 1 foot, and then I think we'll go from there, just since we want the final answer in feet. Now, the rise over run for ADA compliance is for every rise of 1, you need a run of 12. Now, again, this could be in inches, feet, meters, whatever. So notice our rise is already 1 foot, so I could just put the label of 1 foot on there, so that means I need a 12-foot run. So the question is, how long should this ramp be? So that's Pythagorean Theorem. So we have a squared plus b squared equals c squared. And 1 squared is 1. 12 squared is 144. If I add those together, I get 145 is c squared. To undo squaring, you do things backwards. So take the square root of 145, and let me see what that is. Square root of 145 in my calculator is about 12.04, and there's more decimal places here. 159, and then some more. Okay. And that would be in feet. Now, my dad was a woodworker when he was alive, and if I would say, oh, I need 12.04 feet, he would look at me and probably give me a dirty look and be like, I could care less. He would want to know feet and inches because those are how he would be using a ruler, and so he would want to know that. So I know the 12 feet part, so I'm going to take that 12 feet. I know that part, so that part's good. This part would not make sense to someone who is using a ruler because rulers have 16 little sections on them and inches cut into 16ths. It's not base 10, so you wouldn't be able to do decimals. So what we're going to do is we're going to just take this decimal part. So I'm going to subtract 12 on my calculator just to get that decimal part. And then remember that decimal part, that 0.4159 keeps going, 4, 5, 7 is in feet. And I know that there are 12 inches per 1 foot. So I am going to use dimensional analysis, and I'm going to multiply that by 12 to convert it to inches. So that I know it's about 12 feet, 5 inches, and that should be close enough. You wouldn't want to round down because, again, then that ramp's not going to connect. It's going to fall down. But rounding up would be good. All right, and then the second question is, what is the grade of it? Okay. So grade would be the rise over the run, right? So if our rise is 1 and our run is 12, if I divide that, because again, to get a percent, you take rise, divide by run, and multiply by 100 to convert it into a percent. So as far as ADA compliance goes, they are okay with a grade of 8.3%. Exactly repeating, but if you round it, it would be about 8.3%. All right, let's see. I'm trying to think if there's anything else. Yeah, let's look at the next page just a little bit, and then we'll stop there. Okay, go ahead and try to figure this one out on your own, and then we will see if maybe we can even try to write the formula for this as well. So go ahead and see if you can answer the question, then we'll see if we can just go a step beyond. All right, so let's see what they're asking. It's at what rate? Okay, they're asking for a rate. So really they're just asking for slope because slope is a fancy word for rate. So I'm going to make an input-output chart because it helps me analyze linear data better. So on the third year, she had a profit of what? 45,000? And it stabilized at that, and same amount. Her 8th year was 61,000. So again, you could write these as ordered pairs, like 3, 45,000, and then 8 with 61,000. And go ahead and do y2 minus y1. I'm just going to go ahead and do this. So let me use my calculator here. 61,000. What is that? Minus 45,000. So it looks like that went up by 16,000. So that's my change in y. And this one up by 5. That's my change in x. So if I divide my change in y, divided by my change in x. And again, notice that if I leave the units on here, it's actually more meaningful. This is dollars, and this is years. So do you see how that when you divide, you don't want to multiply by 100, you're just going to divide, and that's going to give you a rate. So it looks like her slope or rate of increase was $3,200 per, and I believe it's years, isn't it? Yeah, per year. Now, if we don't have a lot of time here, but we're kind of on the start to getting an equation here. So we could, now we know the slope, the only other thing we'd have to figure out is her starting amount at year 0, and then we really could write a formula on this. The top of page 319 is in a future video. It might be with 3.6. So if you want to see that next page, you're going to have to wait till you get there.